Hello, in this video we are going to be estimating limits with particular emphasis on looking at their tables and taking a look at the graphs as well. Probably the coolest thing that I'm going to be showing you in this video is actually how you can do some of this stuff on your calculator. So here is our first example. I've already graphed the function and we are given a collection of tables and we have to figure out which table matches up with this function. It's very easy to do this on your graphing calculator. I've taken the time to type this into my graphing calculator. You can also get the nice graph if you press the graph button. And we can see based on this graph, the limit seems to be at 1, 2, 3, 1, 2, 3, because I've got a regular about 10 by 10. So at about 1, our limit seems to be 3. Um, well, but what about the table? But what about the table? So if I check my table, I'm actually going to press the right button. If I check my table, I'll notice that, yeah, it does seem to be at about 1, there is an error. So that narrows it down to one of these 3. However, these ones are going by 0.1s, and mine is going by 1s. So it's really tough to tell exactly in terms of the table, where is my function heading towards. So one thing that you can do is you can play around with your table set. So inside of your table set, the first number is like the start number, what's at the top of your list. These all seem to be zero point 0.7. So I'm going to make this zero point 0.7 so it can help match with what's on there. The next is your delta table, and that's saying like, okay, how much of a step do you want to go as you move from one number to another? Before it was like 1, 2, 3, 4, 5 because my delta table was by 1. I want to go by 0.1s. So then it will go 0.7, 0.8, 0.9, 10, etc. So now when I go to my table, now you can see that these numbers are matching up 0.7, 0.8, 0.9, 0.7, 0.8, 0.9. So then I can tell more easily which one is my correct one. So this is my correct table because it is matching up with the material that's on there. We could also say that the limit as x approaches 1 of y1 seems to be, even though it doesn't actually ever reach that point, seems to be 3. That we have a limit here, even though the function blows up when you put in that value of 1. It gets closer and closer to 3 the closer we get to the number 1. But once you put in the number 1, it blows up. In this example, we want to make a table of values to estimate what the limit of this function is going to be. I've also made a graph over here, and it seems to be, as we're approaching 1, we're somewhere around here, but it's really tough to tell based on the graph. So I'm going to go to my calculator in order to make a table. So I've typed in that function. My table set, I have it set to the default. But when I go to my table, unfortunately, it's still not very clear. At 1, I can tell there's an error. Before it's at 1, and then it's at like 2.3. And I can't really tell because the table itself is not very clear. So I'm going to make an adjustment to my table. I am going to set my table set. I am actually going to leave those top things alone. And what I would like to do is I want to be the one that puts stuff in the table. I don't want it to like figure stuff out for me. I'm going to be the one that puts stuff in, and I'm going to set my independent to ask. So now when I go to my table, it's blank. And what I can do is I can type in whatever numbers I want, and I can approach 1 in a way that works for me. So I'm going to have my first number be 0.9. And then I'm going to do 0.99 to get even closer. And then I'm going to do 0.999 to get real close. And I'm going to do 1 because there's my error. And then I'm going to be just on the other side of 1. So 0.001. And then 1.01. And then 1.1. So see there, I was able to have a lot more control about how I was approaching that number, and I can get a better representation of where this thing is heading towards. And now it's a lot more obvious. It seems to be 1.6 repeating, which I know to be 2/3. So this limit is approximately 2/3. thirds. I couldn't tell it based on the graph. It is just an estimate, but it seems based on like putting these values into the table, it's approaching 2/3. In this example, I want to complete the table and get a rough estimate of what's going on with my limit, and also take a look at the graph of the function. So I've typed that in. I'm going to go to my graph first, so just I can get an idea of like what's going on. So let's see, 1, 2, 3, 4. Man, that is really tough to tell. So I'm going to adjust my window so that I can see a little bit better. It seems to be positive, so I probably only want to go to maybe about 6 in terms of my x values. And I like to see the y-axis, so that's why I've got -1. I'm going to go about -1 right there, and I don't need to go very high at all because it was really right on that x-axis. So I'm just going to go to about 2, and then I can get an idea of what's going on here. So let's see. This is 1, 2, 3, 4. So it looks like it's not going up very high, maybe somewhere around a third. But I mean, I'm just kind of guessing based on what's going on with this window. So I'm going to check the table. Oh, in my table, I got a bunch of values I don't want. What can I do? Well, if I just hit this delete button, it'll just delete the values that I don't want. Okay, then I need to just type in the values that are here on this table. Okay, got those numbers typed in, and as I'm looking at these values, at 4, the function doesn't work. I get just an error. However, as we get closer and closer to that, you can see it's like 0.3, 0.33, 0.33. I bet if I did another one, it would maybe do like about 4 threes. So it seems to be about 0.3 repeating. So that means that this limits, I was right before, it's approximately 1/3 based on those values that I'm finding in my table, and also based on the kind of rough look that I made of that graph. And that's it for estimating limits. Keep in mind, like whether you use a graph or a table, it should be heading towards that same thing, coming in from the left, coming in from the right. What is coming in from the right? What is the natural progression of those numbers as you get closer and closer to that particular value without ever actually reaching that value? Thanks for watching. Bye bye.